It was late one night, deep down one of those internet rabbit holes we all know too well, when I stumbled upon something that genuinely stopped me in my tracks. I was looking into the early days of personal computing, the kind of stories you think you know, Apple II, the Mac, the rise of Microsoft. But then I saw it, tucked away in an old forum thread. A claim so audacious, so contrary to the prevailing narrative, that I initially dismissed it as pure conjecture. The claim was this: the Apple Newton, that infamous punching bag of 1990s tech, the device most people remember solely for its laughably bad handwriting recognition, was not just a failure. It was, in fact, a technological marvel so far ahead of its time, so fundamentally brilliant in its underlying design, that it secretly, yes, secretly, wrote the foundational code, the very philosophy of the iPhone years later. My first thought was, that can't be right. My second thought was, if it is right, then we've all been missing a huge piece of Apple's story. And so began a journey that took me through old design documents, forgotten interviews, and the quiet confessions of engineers who were there. What I uncovered was not just a story of a device, but a story of vision, of perseverance, of ideas that were simply too good to die, even when buried under a mountain of public ridicule. It's the story of how Apple's most spectacular failure contained the seeds of its greatest triumph, a truth hidden in plain sight, waiting to be rediscovered. Asterisk, the late 1980s were a fascinating, almost frantic time at Apple. The Macintosh had been a revolutionary success, establishing Apple as a force in personal computing, but the company's leadership, particularly CEO John Sculley, was already looking for the next paradigm shift. They understood that the desktop computer, while powerful, was not the final form factor for interacting with information. The vision was ambitious, almost utopian, a device that would serve as a truly personal assistant, anticipating needs, connecting people, and making complex tasks simple. This vision was famously encapsulated in the 1987 Knowledge Navigator concept video. If you haven't seen it, you owe it to yourself to look it up. It showed a professor interacting with a tablet-like device that featured a voice-activated intelligent agent, dynamic multimedia, and seamless connectivity. It was science fiction, pure fantasy for its time, but it ignited a spark within Apple. This wasn't just about making a smaller computer. It was about creating a new kind of relationship between humans and technology. The project that would eventually become the Newton Message Pad began to coalesce around 1990. It was a blank slate, an opportunity to reinvent computing from the ground up, freed from the constraints of the desktop metaphor. The team tasked with this monumental undertaking was a mix of seasoned Apple veterans and brilliant new recruits. They were given an incredible degree of autonomy, a mandate to innovate without compromise. Their mission was clear, if daunting: build a device that felt truly personal, intuitive, and powerful enough to be useful beyond simple note-taking. This meant rethinking not just the hardware, but, crucially, the entire software architecture. They weren't just porting a desktop operating system. They were creating something entirely new, something that needed to manage information in a fundamentally different way, a way that was more human, more adaptable, and more intelligent. The pressure was immense. The stakes, both for Apple's future and for the trajectory of personal technology, could not have been higher. The world was waiting for the next big thing, and Apple was determined to be the one to deliver it. What few people understood at the time, and what has been largely forgotten by history, is the sheer technical audacity contained within the Newton's operating system. Forget the handwriting recognition for a moment. Underneath that famously flawed interface lay an architecture so advanced, so conceptually distinct from anything else available in the early 1990s, that it reads like a blueprint for future computing. At its heart was Newton's script, a dynamic, object-oriented programming language designed from scratch for the device. Unlike traditional compiled languages, Newton's script allowed for dynamic linking and modification of code at runtime. This meant that the device could adapt, update, and even heal itself on the fly, a level of flexibility unheard of for embedded systems of its era. This wasn't just about making apps. It was about creating a living, breathing software environment. But the real revolution lay in how Newton OS handled data. Instead of a conventional file system, the Newton used what its creators called the soup. Imagine a giant, interconnected database where every piece of information, a note, a contact, an appointment, even a drawing, was an object. These objects weren't stored in rigid folders but rather in a fluid, interconnected soup of data. Applications didn't own data. They merely provided different views into the soup. This meant information could be accessed, related, and utilized by any application, without the user ever having to worry about where a file was saved or which program owned it. It was a profoundly user-centric approach, prioritizing information over application silos, a concept that continues to challenge desktop operating systems even today. And then there were the agents. This is where the Newton truly peered into the future. These were small, intelligent programs designed to automate tasks and anticipate user needs. For example, if you wrote "Meet John for lunch tomorrow at 1 p.m., an agent would recognize "Meet John," create a contact card if one didn't exist, schedule a lunch appointment, and even suggest a location based on your previous habits. If you dragged a name from one part of a note to another, an agent might offer to create a new entry in your address book. This was not just rudimentary automation. It was a nascent form of artificial intelligence, a proactive assistant attempting to understand context and act on behalf of the user. In an era where most personal computers were glorified typewriters and calculators, the Newton's agents were a radical glimpse into a future of truly intelligent, responsive devices. It was an operating system built not just to compute, but to understand. With such groundbreaking technology beneath its surface, one might expect the Newton Message Pad, launched in August 1993, to have been a resounding success. Instead, it became one of Apple's most notorious failures, a cautionary tale whispered in boardrooms for decades. The story of its public reception is a masterclass in how powerful ideas can be undermined by a combination of hype, technical immaturity, and perhaps a world not quite ready. Apple, under John Sculley, invested heavily in marketing the Newton. It was billed as nothing less than a revolution, the future of personal computing in the palm of your hand. The expectations were stratospheric, but when the first Message Pad hit store shelves, reality clashed violently with the vision. The most glaring and ultimately fatal flaw in the public's eyes was its handwriting recognition. While Apple's engineers had achieved remarkable feats in developing a system that could learn and adapt to individual handwriting styles, it was far from perfect. And unfortunately, perfection was what the public had been led to expect. The device frequently garbled words, misinterpreting lunch as latch or party as panty. These glitches, while arguably fixable over time, were relentlessly highlighted by the media. Cartoons like The Simpsons and satirical strips like Doonesbury mocked the Newton mercilessly, embedding the image of a confused, incompetent device into the cultural consciousness. The phrase "beat up a rich kid and take his Newton" from The Simpsons became a darkly humorous epitaph. Beyond the handwriting, the Newton suffered from other practical issues. Its initial price point at around $700 was steep for a device whose utility wasn't immediately obvious to the average consumer. Battery life was adequate but not exceptional, and its bulk, while small for a computer, felt large for a personal digital assistant. It was often slow, struggling to keep up with its own advanced software on the limited processors of the day. Internally, Apple was in turmoil. John Sculley, who had championed the Newton, departed just months after its launch. The company cycled through a series of CEOs, each grappling with a struggling product line and a market that was rapidly changing. The Newton project continued through several iterations, with significant improvements to both hardware and software, including much better handwriting recognition. But the initial negative perception had calcified. The damage was done. When Steve Jobs returned to Apple in 1997, he famously killed the Newton line in 1998, viewing it as a distraction from his efforts to revitalize the company. To the world, the Newton was dead, a fascinating but ultimately doomed experiment. But as we will see, death in technology is often merely a transformation. The public execution of the Newton by Steve Jobs was seen as a decisive move, a clear signal that Apple was moving beyond its past failures. Jobs, ever the pragmatist, argued that the Newton had been ahead of its time and lacked the fundamental usefulness that he believed defined Apple products. But to assume that the Newton story ended there would be a profound misunderstanding of how innovation actually works at Apple, and indeed, in many technology companies. When a project as massive and ambitious as the Newton is canceled, it doesn't mean all its brilliant engineers suddenly vanish into thin air, nor do their groundbreaking ideas simply evaporate. Far from it. Many of the talented individuals who poured their hearts and minds into the Newton moved on to other divisions within Apple. They carried with them not just their experience, but their deep understanding of object-oriented design, dynamic systems, and the user-centric philosophy that had driven the Newton project. Crucially, the intellectual legacy of the Newton found a fertile new ground within Apple through a less obvious but equally important channel, NeXT step. When Apple acquired NeXT in 1997, bringing Steve Jobs back into the fold, it wasn't just about Jobs. It was about NeXT's sophisticated, object-oriented operating system. What's often overlooked is the philosophical kinship between Newton OS and NeXT step. Both were built on the idea of powerful, reusable software objects, dynamic binding, and a vision of applications as flexible interfaces to data. The NeXT step operating system eventually became the foundation for Mac OS X and subsequently iOS. The Cocoa Touch framework, which iOS developers use to build applications, has direct lineage to NeXT step's Cocoa. This meant that the very bedrock of the iPhone and iPad software environment was built upon principles that resonated deeply with the Newton team's original vision. Concepts like the soup, the idea of a central, intelligent data store that decoupled data from specific applications, found echoes in later Apple technologies like Core Data, which allows iOS applications to manage complex data models more intelligently and efficiently. The Newton's profound emphasis on a unified, relational approach to information, rather than a fragmented file system, was quietly resurrected and refined. The Newton's failure wasn't a dead end, it was a pivot point. The technological seeds nurtured by a passionate group of engineers were not abandoned. They were transplanted, allowed to lie dormant for a time, waiting for the right moment, the right hardware, and the right leadership to blossom into something truly revolutionary. The story isn't about direct code reuse, but about a transfer of profound intellectual capital and a persistent design philosophy that refused to be forgotten. So, how did this failure secretly write the code of the iPhone? The connection isn't always a direct line of code copied and pasted, but rather a profound philosophical and architectural influence, a deep spiritual lineage. When the iPhone was unveiled in 2007, it wasn't just a phone with a great screen. It was a new way of interacting with digital information, and much of that newness had its roots in the Newton's forgotten vision. Consider the core tenets of the iPhone's operating system, iOS. It is fundamentally object-oriented, highly dynamic, and designed to present information in an intuitive, user-centric way. These are all hallmarks of Newton OS. The underlying frameworks that power iOS, as mentioned, descend from NeXT step, which shared the Newton's belief in the power of reusable objects and dynamic systems. Think about the intelligence embedded within iOS. The Newton's agents were visionary, attempting to anticipate user needs and automate tasks. Fast forward to today's iPhones, and you see this vision fully realized. Siri suggestions, proactive search, intelligent automation in the Shortcuts app, focus modes that learn your habits, these are all direct descendants of the agent concept. The iPhone is constantly trying to understand your context, predict your next action, and offer relevant information or shortcuts. This isn't just a feature, it's a core design philosophy inherited from the Newtons' attempt to build a truly intelligent personal assistant. Furthermore, the iPhone's multi-touch interface, while not directly from the Newton, certainly benefited from the Newton's pioneering work in stylus-based interaction. The Newton was one of the first devices to truly prioritize direct manipulation on a screen. While the stylus was eventually replaced by fingers, the concept of directly interacting with digital objects, rather than through a mouse and keyboard, was a crucial stepping stone. The Newton taught Apple how to build an intuitive, stylus-driven user interface, which in turn informed the transition to touch. The very idea of apps being windows into a unified data environment, where information flows seamlessly between different functions, echoes the Newton's soup. While iOS has a file system, its emphasis on sharing and integration between apps, and the idea that data isn't rigidly siloed, is a continuation of that data-centric vision. The iPhone wasn't just a phone. It was a highly personal, intelligent, and interconnected device that lived in your pocket. Exactly the kind of intelligent personal assistant the Newton team had dreamed of. The public ridicule of the Newton had effectively masked its profound engineering achievements, allowing those very ideas to be refined and reborn, unburdened by past expectations, in the form of the device that would redefine an entire industry. Asterisk, the story of the Apple Newton, then, is far more than a cautionary tale of a product that failed to live up to its hype. It is a powerful testament to the often circuitous path of innovation, and a reminder that true genius can sometimes be too far ahead of its time, its brilliance only fully appreciated in retrospect. What the world saw as a clunky, overpriced toy with terrible handwriting was, in reality, a crucible for ideas that would utterly reshape our digital lives. The Newton taught Apple, and by extension, the entire tech industry, invaluable lessons about interface design, object-oriented software architecture, and the profound potential of a truly intelligent, context-aware personal device. Its engineers forged new paths in dynamic systems, anticipating the fluidity and adaptability that we now take for granted in modern operating systems. The concept of agents was a prescient glimpse into a future where our devices don't just execute commands, but anticipate our needs, proactively helping us navigate our increasingly complex world. Ultimately, the Newton's greatest triumph was not its sales figures or its critical reception, but its quiet, almost invisible, influence on the future. Its public failure freed its core philosophy and its most talented engineers to pursue those ideas without the baggage of consumer expectations, allowing them to resurface years later, perfectly timed with advancements in processor speed, battery technology, and wireless connectivity. The iPhone did not emerge from a vacuum. It was built on decades of experimentation, on countless hours of ingenious engineering, and yes, on the lessons learned from previous attempts, both celebrated and maligned. The Newton reminds us that true innovation is rarely linear. Sometimes, the path to groundbreaking success is paved with noble failures, and the most profound legacies are often written in the code of devices that were, for a time, utterly forgotten. The ghost in the machine of the iPhone, that core philosophy of intuitive intelligence and seamless interaction, truly began with the Newton. Subscribe if you want more stories like this.